Hello, everybody. Welcome to Lesson 5 of the Math SAT Bootcamp. Today, we'll be going over problem solving and data analysis. Specifically, we'll be taking a look at ratios, rates, proportional relationships, and units. So we'll start off with ratios. Ratios are a comparison of two quantities. And so we've got three main forms that those can be expressed as. We've got A to B, A colon B, or A over B as a fraction. So A to B is what you might see in a word problem, and then those two on the right are what you would see mathematically. So it's probably what you'll work with while you're doing problems. Proportions are equalities of two ratios. So you can see here the two mathematical ways you would represent that. Um, and typically you're going to want to work with them in fraction form because then you can just do math like you're used to doing. You can see here they're all variables, but ratios in general and specifically in proportions can have any combination of variables and numbers. And oftentimes you'll see proportions with just one variable and you'll have to solve for that variable or things like that. Maybe you'll have two sets of proportions and each one will have two variables and you'll have to figure out if those are equivalent. So you can do that as well. And rates, they are a ratio of quantities that have different units. So usually when we talk about ratios, they're going to have different units, but rates specifically are usually going to have a unit of time. So you might see meters per second, miles per hour, feet per second, something like that. If we're talking about water flowing out of a pipe, you might say liters per second, something like that. So it's typically going to be some unit of measurement over a unit of time, but the definition is just a ratio of quantities that have two different units. So you can see three different ways you might express that. You could have a fraction with the variable and the unit on the top and the bottom. You can express it in word form, which is what you would see on a word problem. Or you can have this shorthand on the right here, which is probably what you would write your answers in. So there are going to be two main types of ratios, part to part and part to whole. So we've got a lemonade example to help visualize that. So we're going to say that we have lemonade and the only two ingredients are lemon juice and sugar. So if we're comparing lemon juice to sugar, those are both parts of the whole. Whereas if we're comparing lemon juice to the lemonade, we're comparing a part to the whole. So to visualize this, we'll go ahead and draw a little pie chart here. And this pie chart is going to represent our lemonade. So that's what the whole is. And we can divide it further into two parts. So we'll have this much, and that'll be sugar. I'll put S for sugar. And we'll have this much over here for lemon juice. I'll put J for juice. And so you can see when we have a part-to-part comparison, we're just comparing this part to this part. Whereas if we're doing a part to whole, we might be comparing the juice to the whole. And you can see the whole contains the juice. That's something you want to keep in mind. So we'll move on to some practice questions. Okay, so first up, a geneticist conducts a study to investigate the prevalence of a certain genetic marker in a particular population of US adults. During the study, the geneticist observes the genetic code of 1,000 randomly selected US adults. So before we go on, we're going to go ahead and point out that it says they observed 1,000 randomly selected US adults. So if we go ahead and make our pie chart, that whole is going to be 1,000 adults. And then we can go ahead and keep reading. And it says that it finds that 350 of those adults have the genetic marker. So if we think about each individual person, they either have the genetic marker or they don't. So those are going to be our two different groups. They either have the genetic marker or they don't have it. So if 350 of them have it, and we can go ahead and draw 350 here, I'll make that a capital G. Those are the people who have it, and there are 350 of them. And those are our two parts. We've got big G who have it and little g who do not have it. And our whole is 1,000. So we can go ahead and solve for little g. It's just going to be 1,000 minus 350, which is going to come out to 650. So anytime you have all of the parts but one, and you know how big the entire population is, you can go ahead and find the missing part. So from here, we can go ahead and look at what the question's asking us. It says, according to the results of the study, what is the ratio of observed adults with the genetic marker to observed adults without the genetic marker? So we're looking at with and without. And we already solved for both of those. So if our proportion is going to be with the marker to without, then we're looking at big G to little g. And that's going to be 350 to 650. And you can see here, that's not one of the answer choices. These are much smaller. So what that means is there's some sort of common denominator that we could use here. So keep in mind that whenever you have a proportion, if you multiply or divide both sides by the same thing, then that proportion is going to remain equivalent. So in this case, we're going to go ahead and divide each side by 50. And if you do that, you'll get 7 to 13. So A is our answer. On the next question. This one says that it takes 22.5 milliliters of a diluted sodium hydroxide solution to neutralize a 5 milliliter sample of fruit juice. The amount of solution required is proportional to the amount of juice. How many milliliters of the sodium hydroxide solution would it take to neutralize a 240 milliliter sample of the same juice? So in this case, we've got an initial circumstance and a final circumstance. So let's look at our initial circumstance. We've got 22.5 milliliters of our diluted solution and 5 milliliters of fruit juice. So we'll go ahead and write the proportion for that one. We've got 22.5 milliliters of our diluted solution. And that's going to be proportional to 5 milliliters of fruit juice. If you look here, it says the amount of solution required is proportional to the amount of juice. So what we did is we went ahead and wrote that proportion. And I'll just go ahead and label these. We've got our diluted solution on the left. I'll just label that D for diluted, and our fruit juice on the right. So I'll label that F for fruit juice. And now let's look at the final situation, okay? So we've got 240 milliliters of fruit juice. I'll go ahead and write a second ratio that's equal to the first one. So we've got a proportion set up here. And we don't know how many milliliters of diluted solution we're going to have. That's what we're solving for. But we do know that we're going to have 240 milliliters of fruit juice. So now I'm going to go ahead and rewrite the ratios of the proportion as fractions. That way we can do some math on them. So on the left here, I'm going to have 22.5 milliliters of D, our diluted solution, over 5 milliliters of F, our fruit juice. That's going to be equal to D, which we're solving for. And I'll go ahead and make that big D. That way we don't have to worry about getting these two confused. And then on the bottom, we've got 240 milliliters of F, fruit juice. And so now all we have to do is multiply both sides by that 240 milliliters of fruit juice. And we'll get D is equal to 240 milliliters of fruit juice times 22.5 milliliters of that diluted solution divided by 5 milliliters of fruit juice. And go ahead and look at the units. We've got milliliters of fruit juice on the top and on the bottom, so we can cancel those out. And then we're left with just milliliters of diluted solution. So those are the units that the answer is going to be in, which is what we want, right? Because it was asking how many milliliters of the diluted solution. So if you go ahead and plug those numbers in, you should get that D, which is the amount of sodium hydroxide solution it would take in milliliters. You'll get 1080 milliliters. On to the third problem. It says a banana bread recipe that makes 4 loaves calls for 12 bananas. So it's going to be the same thing. We're going to have an initial ratio. So we can go ahead and write 4 over 12. And remember our units, we're going to have loaves and bananas. And instead of using the colon, I just went right into fraction form. That way we can go ahead and do our math. And what's our final ratio going to be? Well, it says that Bruce is making 24 loaves and it's asking how many bananas does he need. So the bananas is going to be our unknown. So we'll set that equal to, we know there's 24 loaves and we don't know how many bananas. So I'll just do a capital B for bananas. So what we can go ahead and do is multiply both sides by B. So then we're going to have B times 4 loaves. B times 4 loaves over 12B equals 24 loaves. And then we're going to have to multiply by 12 bananas and divide by 4 loaves on each side. That way we get B by itself. And we'll get that B is equal to 12B times 24L over 4L. And go ahead and look at our units. We've got L on top, L on bottom. Those are going to cancel out. So our final unit is going to be B bananas, which makes sense. That's what it's asking, how many bananas. And you're going to get that B is equal to 72. So 72 bananas. So going on to the last problem now. It says that the ratio of the amount of vitamin A in cow milk to the amount of vitamin A in goat milk is 3 to 4. If a liter of cow milk has 1,560 international units of vitamin A, how many international units of vitamin A are in a liter of goat milk? So same thing. We're going to have an initial ratio and a final ratio. We're going to set them equal, and that's going to be a proportion. So our initial ratio, it gives it to us right here, 3 to 4, and that's cow milk to goat milk. So we have 3 over 4. And it's cow milk to goat milk, so we'll do C for cow milk, G for goat milk. And let's look at our final. We're going to have 1,560 IU for cow milk. So we know cow milk, it's going to be 1,560. And we don't know for goat milk. That's what we're solving for. So I'll go ahead and make that capital G. So you can see it's the same setup as last time where we have our variable on the bottom. So instead of bothering with that math, what we can go ahead and do is just bring G over here and bring this whole fraction over to the other side. But if we're bringing it to the other side, then we have to flip it as it goes. So instead of being 3/4, it's going to be 4/3. It's got to flip over. And that'll tell us that big G is equal to 1,560 C times the fraction 4G over 3C. So look at our units. We've got a C on top and a C on bottom. Those are going to cancel. And we're left with G, which makes sense. We're solving for goat milk. And if you go ahead and plug that in, you'll get that G is equal to 2080 G But we're not done yet because if our units are G, that doesn't match the units that the problem was using. So we have to go back and think about what G means. So we said that G is equal to the amount of vitamin A in goat milk in international units. So that goes ahead and tells us our units, it's IU. So our final answer is going to be 2080 IU. So that concludes all the practice problems for today's lessons. So if you haven't already, go ahead and download the Blue Book testing application and sign in with a College Board account. If you don't have one, try making one. And if you have difficulties with that, you can go ahead and send me a message and we can get that figured out. And you'll need it set up by Sunday, which is when we will take a practice test using it. And that's all for today. Thanks for watching.